Okay, so a few things to note before we get started on turning threads. You're going to need a couple other items beside what's included in the kit. This includes a fishtail gauge. Is a good idea to have, and we'll show this in detail in a few moments. You'll also want to have a thread pitch gauge. This will help you measure to make sure you're cutting your threads correctly. If you don't have a thread pitch gauge, just make sure you have a screw or a bolt around that's available to use it in place of a pitch gauge. And then last item is have a nut to check the fit as we go. If you have, you can get go, no-go gauges, but this is kind of the poor man's gauge, if you will, to be able to check to make sure your threads are going to fit. Now we'll also need a workpiece, and that workpiece should already be turned. So I've got a piece in the 3-jaw chuck over here, and it's turned down to roughly 0.190 in diameter because we're going to be making a 1032 screw, and 0.190 is the major diameter. So you want to have that done and ready to go before you start here, because we have to take the motor off of the lathe in order to clear the hand wheel and some of the gearing in the way that it fits by default. There are a couple of tips out there on modifications you can make, but for now we're just going to follow the manual and use the kit as is without any modifications. Also, you don't need to take everything apart as I have here. I've just done it so you can see how it goes together. Some of the gears may already be on the armature as it comes from the factory, because there are some common ones that fit a wide variety of thread sizes. So you'll see, you'll use, for example, when we get to gear A, which is this column here, anything from 39 threads per inch down to 5 threads per inch uses the 100-tooth gear. Once you get into some of the anywhere from 80 to 44 threads per inch, then you'll need to go to a different gear. So some of these gears you won't have to change out very often depending on the sizes that you typically cut. So you'll need this chart, and then also on the chart are shown a couple of the diagrams. They're labeled A, B, C, D, and E, with the idler gear being E. The first time I put this together, I swapped D and E, thinking it was A, B, C, D, E in order. Not really paying attention to the directions closely as I should have been. For left-hand threads, you'll replace the idler gear E with 2 idlers F and G, but we're just going to stick with right-hand threads for now. So the first gear we're going to put on is 100, and I'm assuming that's 100 teeth. Next, I'm going to take the support arms and slide our support arm over our shaft at the bottom. So this is our lead screw support down the bottom. And you want to make sure that these teeth mesh. In the kit, there are only 2 gears that have an arbor pressed on it already. This is a 100-tooth gear, which is our gear B. And you'll use that for nearly everything, except for some of the left-hand threads want to use a 50-tooth, and they don't supply. You'll have to remove the shaft and press it into the 50-tooth if you do larger left-hand threads, starting at 19 threads per inch in the left hand. You'd have to swap that out. Best bet is to get a spare gear and shaft if you are going to be doing those very frequently. They do also include a 127-tooth gear B, and this is for turning metric threads on an inch lathe. So we've got gear A and B. Now we go to gear C, which according to the chart should be a 20. That just slides on there like so. Next we're going to go to gear D, which goes over the shaft to our lead screw, and this is a 32. So it's kind of convenient that the number on this for a lot of the threads lines up with the number of threads per inch that you're going to be doing. So a 32 will do 32 threads per inch, 28 will do 28 threads per inch, so on and so forth. Then we're going to secure that on there with a washer and screw. So we're going to use a 40 for our idler gear. And there are 2 of these included in the kit, at least there were with mine. There seem to be a couple of spare pins and a couple of spare pieces and parts in the kit, which is nice in case you lose any. This is basically just a flanged bearing that slides into the gear. And we're going to secure that onto the second support arm and just do it loosely so it can slide. We're going to swing this over and make sure that we can mesh with both of those. And this is our gear E, our idler. And once we mesh it and we can lock it down there, we're going to tighten this nut at the top, or the screw at the top, to hold everything in place. Now we want to make sure that we can still turn everything. We don't have any binding in the threads. I would recommend, particularly if you're going to be doing multiple screws, putting some light machine oil on a few of these, and it'll spread around to the others. That'll make the turning go much smoother. Last piece we need to attach is the hand wheel. Now this armature you can actually swing to the front, but this hand wheel will still impact the motor. So I'm probably going to be looking at purchasing a longer belt and moving the motor off the lathe so I don't have to take it on and off each time I do this. And there's just a set screw to hold that on, and then I've also attached the handle here, as you can see. And that's all we need to do on this end. So again, make sure everything runs smoothly. Add some machine oil if you need to. Having too much is better than not enough. Just put down some paper towel to catch the drips. Okay, so now we come back around to this view of the lathe. And I've put the tool that came with the kit, which is an East-style brazed carbide tool, into the rocker tool post. Now I've switched back to the rocker tool post just to show you don't need anything fancy. If you have a quick change tool post, go ahead and use that. It's whatever you've got, feel free to use it. Now I still have our lever over here in the disengaged position. Now with my tool post still loose, we're going to bring in our fishtail gauge, line it up with our cutter, and then get our cutter to where it's perfectly square with the workpiece, and tighten it down. Now we can use this lever to engage our hand wheel. So as you turn the hand wheel, it'll flip over into those slots, and now, as you can see, the cutter is going to move along the length at a synchronized speed with the chuck. So we set our depth of cut with the x-axis, and the manual states to take roughly 3/1000ths for your first pass, and then for passes after that to only use about 2/1000ths, which, depending on the diameter of your workpiece and the material you're using, those are good rules to follow. With brass, we could probably take a little bit of a heavier cut, but we're dealing with a fairly small diameter that's extended out about 3/4 of an inch, and so we may get some flexing at the tip if we were to try to take too heavy of a cut. So as we start our cut, we're pretty much just going to be scratching the surface of the piece. Okay, so you may have noticed that I've switched out our workpiece. I had a gear slip on the other one when I was very close to being finished. So I'm starting back at the beginning. I've made a shorter piece. I've also marked it black here so that you can see it a little bit better. I'm going to take a second cut because that one was even a little bit too thin for our purposes. Didn't even really get through the Sharpie on the piece. So be careful as you come up to the chuck and the unturned portion of the workpiece. And we're going to use our thread gauge to check to make sure that our notches are lining up. So they are in this case. If we'd made a mistake on our gearing, as I did on my first attempt, and if I had done this check and had the camera zoomed in this close, or been using a magnifying glass or something along those lines so you can see this very precisely, I would have been able to correct my mistake, because at this point the threads aren't cut too deep to make a change. Now Shoreline recommends going in 3/1000ths for your first cut, and then just 2/1000ths for every cut after that. On brass, we can probably get away with doing some deeper cuts, at least initially. But because I don't want to risk another gear slip, I am going to keep these nice and light and the turning speed slow. Once you get some practice and get a feel for the attachment and what it's capable of and what its limitations are, then you can look at taking some deeper, more aggressive cuts or spinning the hand wheel faster, things along those lines. So this is a 32 thread per inch cut that we're making here. If you can imagine doing a 64 or even an 80 thread per inch, and you can really see where a magnifier is going to come into play to help you see what you're doing. So if you don't have a thread pitch gauge, you can use another screw. So this is going to basically give us a very simple thread pitch gauge. We're engaged there, everything's sitting in nicely. That's what we want to see. Now you can attempt to use the gauge to determine your depth, and you can see with how close up we are, if I can hold it still, that we still have a ways to go. You can see some space at the top of the threads because they're still fairly square. That squareness is another indication that you still need to cut the thread deeper. On a lot of threads, particularly these smaller ones, we're going to be coming to a fairly thin and sharp ridge without much of a flat at all. And we just keep repeating this cutting process, advancing a small amount at a time. Do remember, as you're taking your depths of cut on the lathe, whatever you set on your hand wheel, you're actually going to be taking off twice that amount of material. Now we're pretty close. Depending on how precise and tight you want the thread to be, will dictate how much you advance the x-axis, whether you do it just 1/1000ths or 2/1000ths at a time. And I am just using a store-bought nut, so it may not be the most precise. If you've got a good set of taps, you may want to make your own test nut or device. So at that point now we can slide it on there. Now with steel, you could take another pass just to help clean up the threads. These are pretty clean, so I'm not going to take another pass, but you just take another pass without moving your x-axis and you'll get another cut. So we still need to do a little bit of cleanup on this screw to make it look a little bit nicer. For this, I've gone ahead and I've disengaged the lever on the front, so we're no longer driving the lead screw. And I'm just going to turn it by turn the head by hand. You could do this under power, but all I want to do is put a little bit of chamfer on the front of that screw. Okay, next up, at this end of the screw towards the head, we've got a point where we couldn't get all the way up to the head. And we've got a little bit of a mess there, so I'm just going to use a cutoff blade, and I've got it mounted upside down in the back. And I'm just going to reduce that diameter. Now if we wanted to, we could also come in and put a little bit of chamfer on there if we wished. But otherwise, that is a finished thread. Now we don't have much, we do have a little bit of wiggle there, so I mean our thread is a little bit loose, but that's not too uncommon. I mean we do spin freely, again just depending on what sort of fit you want is how close you'll take those tolerances. So next let's take a look at a couple of the mistakes I made before I got to this point and how you can hopefully try to avoid those. So you can use some threading or cutting fluid on this. You would definitely want to do it with steel or aluminum. I'm doing the brass dry just again for video purposes so that hopefully we can see these threads a little bit better rather than having them covered in fluid. You want to make sure that you do not disengage that lever on the front until you're completely done. Now let me show you what happens if you get a gear slipping or if you disengage and re-engage that lever. We're pretty much going to ruin these threads. So I've gone back and I've set a shallower depth of cut, but as you can see, we're pretty much just wiping those threads off the face. So this is why it's really important to keep those synchronized, otherwise you'll ruin your piece very quickly. As I just did here. You don't want to do this type of threading under power. If you had a stepper motor or a servo motor connected directly to the Z-axis, then you could probably do this under power if you wished, because you'd be turning at a much slower and much more controlled speed with a controlled number of revolutions. But I wouldn't try to do this with the standard motor on the Shoreline. Okay, so it wasn't actually my intention to show you how to destroy a thread. It just happened by coincidence in this video. Now, I haven't used this accessory very much at all. This was actually only my second attempt. And what happened is on the idler gear, we've got this small bushing, and the bushing is designed to hold this against the second support arm. So the bushing goes in like so. We have a little bit of space here. It's because the bushing is thicker than the gear. And then the support arm sits like so. We take a screw with the washer and we secure that down. The purpose of the bushing is so that the wheel will spin freely, which we definitely get. The difficulty comes into how do we tighten this screw down? Because as we turn the screw, the bushing is just going to spin as well. There's nothing really holding it to where it won't spin. So you can put a little bit of finger pressure on the back to help hold it in there. But if you don't get it on there tight enough, it will slip, and that's what happened on my workpiece. So I lost synchronization between the spindle and the lead screw, thereby ruining the piece. So I'm probably going to end up making a replacement bushing. If you're very careful and you don't get too carried away on the speed that you're spinning the handle at and taking lighter cuts, you're less likely to push this gear out of synchronization. But that's not something you want to have happen on a critical part or a more expensive part. So definitely take your time, do some practice, things along those lines. I'll remake the bushing to where this can't happen, and I'll show that in another video. So I hope you've enjoyed this first video on threading. We'll do another video on internal threading. The tooling there is a little bit different. We'll probably do that as a larger thread as well, and also look at maybe making some more precision cuts and just additional practice that you need to do. And that's really the key with this type of accessory is practice, 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 right? You want to definitely learn the ins and outs of the device before you get to where you're working on a critical piece. So here we have the last item that we actually worked on, which was, again, my third attempt. And this one, the threads do fit nicely. I haven't parted it off yet. I've got another one over here that I'm going to cut, and I'm going to cut these very loose for demonstration on another video. And then this was my first attempt where I cut 40 threads per inch because I had swapped some gears. And then this is the destroyed part where my idler gear slipped and we lost synchronization. So just to give you a finished view of what was done here, and I'm hoping that by showing some of the mistakes I made, that can save you some time and frustration and help you avoid those mistakes yourself. If you enjoy the video, always give it a thumbs up, leave in the comments if you want to see anything new, and be sure to subscribe. Thank you for watching.